Okay, let's pick that up again. The phone, sorry about that, the phone completely filled its memory with the first few minutes of video, first 6 minutes worth of video, so we'll try again. Okay, so here's where we've got to. We'll set up the lens and the axes and F and 2F and so on. Now, we want to put the object beyond 2F. So we'll put the object at 40 centimeters. So that's 5, 10, 15, 20, 25, 30, 35, 40 centimeters from the lens. And we will make the object 2 centimeters high. Now, we don't have to use the same scale on the horizontal and the vertical axes. So the vertical axis can just be a 1-to-1 scale, so we can say that the object is 2 centimeters high, and it actually is 2 centimeters high on the page. Now, that is the object. I hope you can make this out. Right, now we're in a position to try to use the ray diagram to predict where the image will be formed. So we know that many rays of light leave all parts of the object. If we just take one point on the object, like the tip of the head, there are rays of light going in every direction from that. But only a few will actually head anywhere towards the lens. In particular, we're interested in magic ray number 1, which is a ray coming from the head of the object parallel to the principal axis, like so. It goes all the way to the ray axis because we're in this model the refraction happens here at the axis, and because that ray is parallel to the principal axis and the lens is a converging lens, the lens will do what converging lenses do, and it will refract that parallel ray down through the principal focus, like so. Okay, don't forget to put arrows on the rays. Now, that's magic ray number 1, which I'm going to label as such, like that. Okay. Now, magic ray number 2 comes from the same point on the object and heads for the center of the lens, like this. Now, when it gets there, it goes straight through undeviated, for reasons which we discussed on Friday. And like that. Okay. Now, that's magic ray number 2. Okay. Now, both these rays came from the same point on the object. So where they meet on the other side of the lens, that must be where we would be able to obtain a focused image. So the head of the image is right here. Now the foot of the object was on the principal axis. So from that we can assume that the foot of the image will also be on the principal axis, like that. And we can therefore deduce all the points in between to give the whole image, like so. Okay, so there is the image. Now, the image is at an image distance of 5, 10, 15, 20. Well, this one is between 24 and 25 centimeters from the lens. So we'll say it's about 24 centimeters, although at this point we're not too fussed about that, but we'll need to measure that a bit later on. We are fussed about the nature of the image. The image is real, first of all, because it's formed by rays of light that actually pass through it. And if we place a screen here, we can obtain the image on the screen. The image is diminished because it is smaller than the object. The object height was 2 centimeters. The image height is about 1.2 centimeters. And it is inverted, which is to say upside down. Now, if you check back to the table of results you took from actually obtaining images using a real convex lens, the predicted nature of the image should agree with what we actually find. In other words, when we placed an object beyond 2f, the image turned up in between f and 2f. The image was real, diminished, and inverted. So the power of the ray diagram is that simply by using the two magic rays, it can predict where the image is, it can predict what size it is, and it can also predict its nature. Okay, so that's ray diagram number 1. And in the next video, we'll have a look at the second ray diagram. Incidentally, as we mentioned on Friday, although we've just drawn the two magic rays, it's always possible that there are other rays. In fact, there's an infinite number of rays leaving the head of the object and going to the image. It's just that we can't predict where they're going to go by themselves. Once we know that the image is going to be here, we could take some random ray like this one, which happens to hit the lens here. We now know that that ray must be refracted and pass through the head of the image like that. Similarly, a ray that went up here, like that, must be refracted down through the lens like that. And a ray that went, say, down here would be refracted up like that. So in fact, we have a whole set of rays, and all of the rays that come from the object and arrive at the lens will be focused down through this point and therefore form part of the image. So in fact, as we saw in the fluorescein demonstration, what's actually coming from a point on the object is a cone of rays, a cone shape. And the foot of the cone, the base of the cone, is the round lens, and they produce another cone on the other side, and the point of that cone is the head of the image. However, in our ray diagrams, all we need to do is to draw two ray paths in order to locate the image.